Here's number one. Basically, have this box on the floor, and it tells you that you're pushing down on it with force at an angle of 20 degrees. I'll just call this theta. And it also tells you that friction opposes the box. I'll actually draw this friction parallel to the floor, and I'll just call this F. Box obviously has gravity, call this F of G, and it also has a normal force, call this Fn. And of course, this ball has a mass, so you want to break up all of your forces, and you see that this force you're pushing on is going down to the right, so you're going to break it into components that are going down, the components that are to the right. And then you can write this as F sine of theta as the vertical component, and then F cosine theta as the horizontal component. And you should always say which side is positive and which is negative. I'm just going to say that right's positive, up is positive, down is negative, and left is negative. And now we're ready to add up all our forces. So we can add up x, and we can add up y. So in the x, we have if cosine theta. It's going to be positive because it's right, and it's in the right direction. And we also have what's the function, which is going to be negative because it's pointing left. So that's all of our forces in the x direction. Okay, now look at the ones in the y. So we see that we have f sine of theta, which is pointing down, so I'll call this negative f sine of theta. And then we have the normal force, and it's positive, so I'll call this Fn. And then we have gravity, which is pointing down, so negative Fg. And that's all of our forces in the x and the y. So in the x, we can say that F equals ma. And now we have to decide what this acceleration is going to be. Well, it asks us what is the minimum amount of force, this vector here, that we can exert to get the crate to move. Well, what this tells us is that the acceleration has to be something that is greater than zero. But this can be literally, 0.000, continued one, like the smallest possible, non-zero number. But we can basically just say that, the acceleration is zero because we can just round it down and it's, going to be the exact point where there's going to be an acceleration is when the acceleration is zero, if that makes any sense. So, and the f equals ma for the x, we can say that f net equals zero. And the f net is just adding up all the forces, so we can say that f cosine of theta minus force of friction is equal to zero. So it'll be f cosine of theta going to be equal to the force of friction. Now, if you remember, force of the friction, Ff is equal to mu static, um, Fn. So we can just write that here. You could say it'll be mu static Fn. And we could get Fn by using this, using the forces in the y component. So we can add them up together. We get Fn minus Fg minus F sine of theta is equal to zero. And this is zero because the acceleration of the y is zero. The box isn't, going upward into the ground at all. So we can say that the normal force is equal to Fg plus F sine theta. So we can plug this whole thing right into there. So it'll look something like this. It'll be F cosine of theta is equal to U static, it'll be force of gravity plus F sine of theta. And so we see that this has the force and this has a force, so we have to get this one out of this some equation. So first we should distribute this mu across. We'll get F cosine of theta is equal to mu static of g plus mu static f sine theta. And now we can subtract this mu static f sine theta from both sides. And we'll get f cosine of theta minus mu f sine of theta. That's all going to be equal to mu force of gravity. So now we can factor out the force here. I'm just going to draw this up here because I'm running out of room. And it looks like this. It'll be anything to the fourth will be f times cosine of theta minus mu sine of theta is equal to mu times the force of gravity, which when you divide this whole thing across, you'll get the force equal to some long expression on one side. It'll look like F is equal to mu, and I'm just going to call this mg because it's just the force of gravity. It's over cosine theta minus mu sine theta. These are both mu static. And so that is your answer. You get the force, which is just the magnitude of this vector here. And when we plug in all those numbers, you get the right answer. Thank you very much.